Let's now talk about the effect of wing sweep. So I'm going to draw an aircraft here with a swept main wing and pretend like those two wings are symmetrical. And then we've got a side slip angle here, so V infinity, and that's beta. Okay, so if we look at the simplified model of the vortex system here, we know that the vorticity kind of follows the chord line and then is shed. And actually it's a whole vortex sheet back here. But this is what that simplified model of the vorticity looks like. And so what happens when we have some side slip angle is that, well, let's back up for just a second and write this equation here. So lift, from the vortex lifting law, we know that lift is equal to rho times the velocity cross gamma. Okay, so gamma has a direction and velocity has a direction and lift has a direction. Okay, so we take the cross product of the local velocity and the local vorticity and get the local lift that's produced by some vortex segment. Okay, so and actually this is just a total force. We call it lift sometimes, but it's really the total force, and then we can rotate that into the lift and drag, or lift and induced drag components of that. But anyway, so so what happens here is if we look at the whole velocity field that this aircraft is seeing, so this V infinity is actually hitting the aircraft like this. And here we're going to neglect induced velocity due to the wing, so if we just use the free stream velocity here to visualize this, what happens is over on the right hand side, this free stream velocity is more perpendicular than the velocity is, well, it's more perpendicular to this lifting line here, to this vorticity, than the free stream velocity is to the lifting line on the other side of the aircraft. Okay, so from the cross product, now notice that the velocity magnitude hasn't changed because we're neglecting the induced velocity. So the velocity magnitude hasn't changed. And so the difference here, though, is that we've got something more perpendicular on the right-hand side than on the left-hand side, and so the magnitude of the lift will be different on either side of the aircraft. So if we were to look at the lift we're looking here from the back of the aircraft, so the aircraft is flying into the page here. So on the right-hand side, with positive beta, we would actually have a larger lift than on the left-hand side, simply due to the fact that the free stream velocity is more perpendicular to that vorticity than it is on the left-hand side. And so because of that, we get a rolling moment. This is actually a negative rolling moment that is produced due to positive beta and positive side slip. Okay, so this is, so CL beta here is less than 0 for positive sweep. Okay, so if we have positive sweep, and remember that that sweep is defined here as this angle here, and we usually use lambda and maybe subscript it with C over 4. That's the chord sweep. Anyway, you can measure that relative to the leading edge or the trailing edge. But anyway, if we have positive sweep, then we will have negative CL comma beta. Okay. Now, one thing I want to point out here is that this gamma is the vorticity strength here. And so again, that can be confusing because in the previous video, we used gamma to show the dihedral angle, which is also convention. So you just have to remember what gamma means in each of these equations. But here we're talking about the strength of the vorticity. And in the previous one, we were talking about dihedral angle. So one thing that we learn from this is actually if we had negative sweeps. So let me just draw a vorticity distribution here from a wing with negative sweep, we would have exactly the opposite effect. So So CL comma beta would be greater than 0 for negative sweep. So this is one reason to have positive sweep instead of negative sweep. Now there are other reasons as well, but one reason is that it contributes to roll stability, where positive sweep, if you had, I think I said that backwards. This is why we want positive sweep instead of negative sweep. If we have negative sweep, then your sweep is actually decreasing your roll stability, where a positive sweep will increase it.